Section 2.2 is on page 104, talks about inverse direct function. Continue because 2.1 talks about inverse direct functions, but I like to do those sections backwards for many reasons. If we think about this, we're talking about an inverse, and if you recall from algebra, for an inverse to occur, so for an inverse to exist, the definition states the inverse of a one-to-one function. So a function must be one-to-one for you to be able to find the inverse of. And let's look at the graph. So to find the inverse, we replace x by y, if you remember. And if the sign of a value equal a number, y would be the inverse sign. Do you remember that? And that's pretty much how it works for all of those. Now, if I look at the graph of a sign and I'm trying to figure out how I'm going to do this right, I notice the graph of a sign runs between 1 and -1. Oops. Okay, third time will be a charm. And a sine wave looks like this. This is by far the toughest idea to sink in, so you really want to try this as hard as you can. Don't fall behind, and if you have any questions, bring them to the class next time. So what happens? I notice this works. Do you see if I exceed pi over, this is definitely not 1-to-1, do you see that? So do you see I can move as far as pi over 2, and I could move back, but I can't exceed -pi over 2. So for me to talk about an inverse, if I look at the unit circle, if start at 0 and rotate, isn't pi, oh come on, isn't pi over 2 rotating in quadrant 1? But I can't be in quadrant 2, so I can't exceed that. And if I roll back, isn't that negative rotation to -pi over 2? And I can't be there. This is inverse sine of x. If I look at the graph of a tangent, well, I notice, luckily, it behaves almost identical. That is, if I look at a graph, if I keep one cycle, if I run another cycle, I'm in trouble because this is no longer 1-to-1. So at most I could do one cycle, meaning this is really running, this was pi over 2, hey, it matches. And this is -pi over 2, it matches. So inverse tangent works as well. Inverse sine could be, it could use pi over 2 and -pi over 2, but inverse tangent can't because those are asymptotes. Now, cosine is the troublemaker. If cosine was to match, this would be a very simple idea. The fact that if I look at a graph of a cosine and cosine doesn't match and has its own rule kind of make things a bit confusing in the beginning. So, a cosine wave starts on the amplitude, runs down and back up and down and back up. So this is pi over 2. This is pi, 3 pi over 2, -pi over 2, -pi. I notice if I wanted to add the same restriction, that's not 1-to-1. We have a problem. So I notice that I can't use the traditional. What I have to do, I have to start at 0, and I rotate. I could move all the way to pi over 2. That's right there, quadrant 1, inverse cosine of x. And I could keep on moving all the way to pi I could run between 0 and pi. Isn't 0 and pi quadrant 1 and 2? So, if an inverse trig function is positive, we're in quadrant 1. If an inverse trig function is negative, it depends which one you're talking about. If it's cosine, you're in quadrant 2. Right there. That's quadrant 2. If it's sine, you are in quadrant 4, but in negative rotation. So that's going to give you a hard time. I am going to give you a hint. I am going to give you something that's not in the book. I am going to claim the inverse sine of negative x equal negative the sine inverse of x, and the inverse tangent of negative x equal negative the tangent, and that could save you some pain. It seems the odd identity carries into inverse, but not even. Not the even identity. So if I start the problems, and as you see, I want to do few problems, namely all the evens. Okay, this is acting up big time today. Here we are. So I glance at a problem. I'm taking the sine of an angle. My answer is a ratio. This is the sine. Since this is positive, we're in quadrant 1. The sine of which angle gives me 1/2? Either you use the triangle or you use the geometry, right? Trigonometry right there, whatever you want. So, sine of which angle gives me 1/2? Is it sine? Cosine. Cosine of what? Cosine of 30 degrees. So this is pi over 6. And what is the sine of pi over 6? The sine of pi over 6 is radical 3 over 2. There it is. Very simple. And if I get to number 10, I could, here, of course, I always forget to mention, I could, if I want to do it differently, I could have said, let this be theta, because that's an angle. So I'm looking for the sine of theta. You know what? Yeah, I could, let me leave that here, let me do that here. I was supposed, normally I do it on the first. So using the trig or the geometry kind of clear it up, but I could call that theta because that's an angle. So I'm looking for the sine of theta. You could always do that. And I know the sine of theta is the opposite over the hypotenuse. I go on the side and say, look, if theta equal the inverse cosine of 1/2, that means I must have had the cosine of theta equals 1/2. This is if the angle is not standard. And since the inverse sine is positive, I know I'm in quadrant 1. This is the adjacent over the hypotenuse. That makes this a radical 3. And if I want the sine of that angle, that's the opposite over the hypotenuse. So you could work that out any way you like. If I move to number 12, I could say this is the tangent. Now, one way of doing this, for now you could get away with it. I could move the negative and say that's an odd function. What the benefit of that is, that makes this in quadrant 1. It makes the angle acute. And can't I take that negative out because tangent is an odd function? What is the inverse sine of 1/2? Basically, we're asking the sine of which angle gives me 1/2. Well, let's look at this. The sine of which angle gives me 1/2? The sine of 30 degrees or pi over 6. And what is the tangent of pi over 6? There's pi over 6. Tangent is the opposite over the adjacent. And how about this problem? If I look at this, this is the code. So if it's a standard angle, I could use the triangle. If not, I will have to do something like this. This is negative the inverse sine of negative 1/2. And this is negative the cotangent of what inverse, the sine of which angle gives me 1/2, we just did that. That's pi over 6. And what is the cotan of pi over 6? Well, it's really the reciprocal of tangent. Oh, that's why I normally skip that. How about here? This is the secant. If this is positive, we're in quadrant 1. The tangent of which angle gives me radical 3? The tangent of pi over 3 is the opposite over the adjacent. Pi over 3. And I'm looking for the secant of pi over 3. Well, there's pi over 3. Secant is the hypotenuse over the adjacent, 2 over 1. This is the cosine, and I could use the fact that this is odd, take a negative out. And I could say this is the cosine of, and let's see what that is. The sine of which angle gives me radical 3 over 2, so you're working backwards, inverse. Radical 3 over 2. The sine of which angle gives me radical 3 over 2? The sine of pi over 3 is the opposite over the adjacent. So it has to be pi over 3. And isn't cosine an even function? The inverse is not, but the cosine is. And what would be the cosine of pi over 3? There's pi over 3. Cosine is the adjacent over the hypotenuse. That is 1/2. This is the cosecant. Now we're stuck. I can't use the even because that's an inverse. So I ignore the minus. And I look at the cosine of which angle gives me radical 3 over 2. Well, cosine of which angle gives me radical 3 over 2? Radical 3 over 2, that's a pi over 6. That's a reference angle of pi over 6. But if you look at an inverse cosine, and if it's negative, you can only be negative in quadrant 2 for inverse cosine. What is pi over 6 in the second quadrant? And now what is this? This is what we tested you on in exam 1. Cosecant of 5 pi over 6 is the hypotenuse over the opposite, right? The reference for 5 pi over 6, hypotenuse over opposite, so that's 2 over 1. Oh, hypotenuse over opposite, 2 over 1 for pi over 6. And in 5 pi over 6, is cosecant positive or negative? That would be positive because sine is positive. I get the number 22, and I'd like to look at, this is going to be an angle. My answer is going to be an angle. So what I do here, I say this is the inverse tangent of, and let's see what this is. Cotan of 2 pi over 3. Ignore the 2. Cotan of pi over 3 is pi over 3. Cotan is the opposite over the adjacent. And isn't 2 pi over 3 in quadrant 2? Isn't that negative? Can't I suck the negative out because I'm assuming that this is odd? Again, it's an angle. And we're asking the tangent of which angle gives me radical 3 over 2? The tangent of which angle gives me radical 3 over 2? The cotangent of pi over 3 was the opposite over the adjacent. It was 2 over 1. You guys, be careful. So that cotangent of which angle gives me radical 3 over 2? It has to be a pi over 3. And if I look at this, that is the inverse cosine of, what is the tangent of negative pi over, well, that's negative. What's the tangent of pi over 4? Isn't that a 1? And this is asking, again, this is an angle, right? This is asking the tangent of which, the cosine of which angle gives me a -1. That's a standard angle. The triangle can't help you because that's right there. Remember, if you start with an inverse cosine, you can go that much. And what if the angle is not standard? You call this theta. You're looking for the tangent of theta, which is the opposite over the adjacent. And you go on the side and say, you know what? I label this angle theta. So theta equal the inverse cosine of 1/3. Doesn't that mean I must have had the cosine of theta equal 1/3? And if it's inverse cosine and it's positive, you're in quadrant 1. Cosine is adjacent over hypotenuse. That makes this 9 minus 1, 8. And I want the tangent. Isn't tangent opposite over adjacent? And what if I gave you the same problem but I made that negative? You would call this theta still, and you would say, I'm looking for the tangent of theta, and that would be the opposite over the adjacent. The difference here now is that you let theta equal the inverse cosine of -1/3, which means that cosine of theta equal -1/3. An inverse cosine is only allowed to be negative in one quadrant. That angle must be in quadrant 2. How do I know that? An inverse cosine is negative only in quadrant 2. A sine in quadrant 4. Adjacent over hypotenuse. That makes this radical 8, but this is negative. And if I want the tangent, it's the opposite over the adjacent. Now we're going to stop here. There's the homework that you're going to do for this assignment.